Hi guys, welcome to another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over area of parallelograms and trapezoids. This video is going to be split into two parts. Part 1 is going to focus specifically on using the area formula for parallelograms and trapezoids. And part 2 is going to focus on composite figures, the idea that shapes are made up of multiple shapes and that you can find the area of a particular shape multiple ways instead of just using the formula for what you are given. So for part 1, we're going to focus on identifying bases and heights of parallelograms and trapezoids and then using the formula. So let's get started. So first, parallelograms. How do you identify a parallelogram? Parallelograms have two sets of parallel lines that are opposite of each other. Parallel means never going to touch. So if I look at line AB and line CD, I notice they're never going to touch if I extended the lines in either direction. So those are parallel. And then I also notice that line AD and line BC are parallel. They'll never touch. So we use these arrow symbols to note parallel. So line DC is parallel to line AB. Then line AD is parallel to line BC. However, line DC is not parallel to line AD. So that's why they have a different set of markings. Our next characteristic of parallelograms is that the opposite sides are equal to each other. So line AD is going to be the same size as line BC, and that's how we would note sizes are the same. And line AB is equal to line DC. So again, we note that with dash marks, showing that they're the same size or same length. All four sides are not equal on this particular parallelogram, so that's why line DC has a different marking than line AD. Okay, our formula for area of a parallelogram is A equals BH, where A stands for area, B stands for base, and H stands for height. Now, you'll notice that this formula, A equals BH, is very similar to the area formula for a rectangle, which is A equals length times width. Why is that? If you look more closely at a parallelogram, and let's say you cut it off like right there, and move this piece over here, you're essentially going to make a rectangle. Rectangles will have 90-degree angles, so you have a definite length and width, so two parts. Parallelograms don't necessarily have 90-degree angles. They can have the slanted, obtuse angles. So for that reason, we don't have lengths and widths. We simply have bases and heights. But it's very similar. So parallelograms, A equals BH. Again, that's similar to rectangles, A equals LW. Okay, let's start with identifying bases and heights. If you don't know what the base and height is of a parallelogram, you won't be able to use the formula. It will be of no use to you. So, three things. First thing, bases can be any side of a parallelogram. So the base can be any side. So on my three examples, on the first one specifically, line EF could be my base, line FG could be my base, line GH could be my base, line FE can be my base. Any side can be the base. Second thing to note, the base and height must meet at a right angle. Again, the symbol for right angle is that little square. Notice that none of these parallelograms have a right angle. They all either have obtuse or acute angles, no right angles. So what does that mean? That leads us to our third important piece of information. Before we identify bases and heights, we need to know that you cannot use a side of the parallelogram for the height. Again, you cannot use any side of a parallelogram for the height. Why? Because they don't form right angles with the base. What does that mean? You're going to have to draw in your height if you're identifying it that way, or you have to look for a right angle if you're going to identify it if it's already there. For example, if I look down here, this 8 or this 5 could be my base. But which line forms a right angle with the numbers? Well, if I look at this 5, I don't have that distance from this side to that side. So I would not use this number. If I look at the 8, do I have a line that forms a right angle with it? Yes, right here. So this would be my height. They have to form a right angle. Okay, let's work on these three examples here, identifying bases and heights of parallelograms. So our first one, parallelogram EFGH. Any side can be the base, so I'm just going to let line FG be the base in my first example. Next, how do I find my height? Put a straight edge on line FG, then form a right angle with another straight edge. And there are several options for where you could put your height. I could put my height right here to this vertex, as long as it makes a right angle and the line goes to the other side. I could put it in the middle if I wanted. That would be a bit weird. Or I could put it here. I would strongly recommend that when identifying heights, try to form other shapes. Try to show that there are other shapes inside, and you'll see why when we get to part 2 of this video. So I'm going to draw my height right here up to point E, or that vertex, and you'll notice it forms a nice right triangle right there. That's going to be useful again later. So my base is line FG, and this is my height. Again, it's the distance from one base to the opposite side, but it's got to go at a right angle. All right, next example, parallelogram JKLM. Again, I'm going to use the bottom as my base. I could choose other sides. So I'm going to let KL be my base. I'm going to put my straight edge on that line. Going to make my right angle and choose where to draw it. So in this example, I drew it on the left side. Over here, I'm going to do it on the right side this time. So again, I'm looking to try to make additional shapes in there. So I'm going to draw my height to the vertex M. Notice I made an additional shape in there, that right triangle. So KL is my base, and this perpendicular line right here would be my height. All right, last example. Parallelogram SPQR. I could again choose any side to be my base. For this one, it might actually be easier to use line QR as your base and then draw your height right here. But I'm going to show you other options. So I'm going to stick to keeping the bottom as my base, like the previous examples, and show you what happens when you have something like this that's stretched out. So I put a straight edge on my base. Now the height is going to be the distance from there to the top. But notice the top is way over here to the right. So what do? Well, like on triangle, sometimes your height has to be drawn on the outside. So I would have to draw it all the way up to point R. Just like on triangles, bases must be solid, so the base is simply from P to Q. This is not the base, it's just an imaginary line. This is going to be our height because it forms that right angle. Again, height is simply the distance from the bottom to the top, not diagonal lines. All right. There's an example for finding bases and heights of parallelograms. Let's put that to use. Our first example, we're going to find the area of a parallelogram. So in figure ABCD, line BE is straight. A note of caution, the height of the parallelogram is line DE. So again, this is our height. DC, which by the way would be 5 because opposite sides are equal, that is not the height. Why? Because it's not perpendicular to the base. It does not form a right angle. That, not a right angle. This is a right angle. So, what does that mean? That means line BC is going to be my base. Line DE is going to be my height. What is the 5? The 5 is useless. It's a trick number. It's just another dimension that is not necessary or useful in finding the area on this particular example. So, just a note, you don't need this number for your formula. It is essentially a trick on this example. Now, if you had the height to go with that, then it would be useful. So if I had this distance from here to here in this direction, I could use that 5. But I don't, so it's useless. All right, so I'm going to use this as my base, this is my height. What is my first step? To find the area, write the formula. Always write the formula for what you're dealing with. We are doing a parallelogram. So the area formula for parallelogram is A equals BH. Next, substitute. So replace each variable with what you know. Do I know A for area? No, that's what I'm solving for. So I'm going to keep that as A. Next, equals B for base. Do I know the base? Yes, 8. So replace base with 8. Next, height. Do I know the height? Yes, 4. So replace the height with 4. Last step, solve step by step. If you're doing a parallelogram, you don't have many steps to follow. So A equals, what is 8 times 4? 32. 32 what? We are finding area. Area is all about how many squares of a specific size will cover a shape. So we're talking about centimeters. It's area, so it should be centimeters squared. What does this mean? This means that this parallelogram could be covered in 32 centimeter sized squares. Not sure if that's an actual centimeter or not. I don't have a ruler, so can't measure it. Please don't forget that area has square units. Again, area is all about how many squares will cover a surface. So what use is knowing area? If you want to buy carpet, flooring, paint for walls, all of that good stuff, you're going to need to be able to calculate area so you know how much covering that you would need. All right, we're going to switch to trapezoids now. Okay, what do I need to know to identify a trapezoid? One thing, and one thing only. Trapezoids have one and one set only of parallel lines. So if you see a shape that it seems to only have one pair of parallel lines, so for example, in this one, line AD is parallel to line BC, and there's no other characteristic, that means you have a trapezoid. Okay, what is our formula for area of a trapezoid? A equals 1/2 times height times, in parentheses, B sub 1 plus B sub 2. That stands for base 1 and base 2. So let's go over our letters. A again represents area. H represents height of the trapezoid. B sub 1 represents base 1, or essentially one of your bases. And B sub 2 represents base 2, or in other words, your second base. So trapezoids have two bases. Why do they have two bases? If you look at a trapezoid, you might notice that you could split it into two different sized triangles. But if you measured it, their heights would be the same. So if I looked at the top triangle, this would be its height. Line AD would be the base, which is kind of small. Compared to this triangle, this base is much bigger, but it has the same height as the other triangle. So these two triangles have the same height, so that's why we only have one H. But I have one big base and one small base. So look at your formula. You'll remember from a previous video, the formula for area of a triangle is simply 1/2 times base times height. But because I have two triangles, that's why we have two bases. So that's the only difference between a trapezoid and a triangle, and that might be useful in helping you memorize what looks like a complicated formula. Knowing that trapezoids have two triangles, so think, okay, what's the formula for that? But then, oh, there's two triangles, so there's two bases. Be sure your bases are in parentheses. Why? Because order of operations state you must solve what's in parentheses first, and that's important. You're going to have to add your bases first. Okay, let's figure out how to identify bases and heights of your trapezoids. Because without knowing that, you're not going to be able to use the formula. So, two things. First, the parallel lines must be your bases. So very straightforward. No choices whatsoever. So again, the parallel lines must be your bases. So none of the sides, like you can't just choose. It can't be any side. The two parallel lines must be your bases. Second, the height must connect the bases at right angles. And so does everything else that talks about height. Triangles, bases and heights must form right angles. Parallelograms, bases and heights must form right angles. It's not any different for trapezoids. And honestly, I think this one's going to be a little bit easier because first, parallel lines must be your bases. So let's use this example, trapezoid EFGH. Which two lines are parallel? Those aren't parallel. Those aren't parallel. Right there. Those two lines are parallel. So it doesn't matter which one's base 1, base 2? Absolutely not. So I'm going to call line FG base 1. That means line EH, the other parallel line, will be base 2. Next, the height has to connect them. So I know the line's going to have to go, well, in this example, up and down. But it has to be at a right angle. So let's put a straight edge on one of the bases. It doesn't matter which one. Make a right angle or a 90-degree angle with the other straight edge. Again, I have choices. It just has to go from this line to that line. I strongly recommend you try to draw your heights or identify heights that appear to form other shapes. So I see a triangle right there. So I'm going to draw my height right up here to point E. So I see a right triangle in there. That could potentially be useful. I'll show you in part 2 how it can be. All right, before I go to the next example, let's label this. Again, height. So base 1, base 2, height connects them at a right angle. Don't confuse this with parallelograms. Parallelograms only have one base. It can be any of the sides, but there's only one base. Trapezoids have 2 bases. So it has 2 different labels. All right, next example. Trapezoid LMNO. Which lines are parallel? Are those parallel? No, they're going to touch eventually. Are those parallel? Yes. So line LO and line MN are my bases. I'm going to call line MN base 1, line LO base 2. The height is going to be a line that connects the 2 at a right angle. So get out a straight edge, form a 90-degree angle. I could draw the height here, could draw the height here, could draw the height here. I'm going to go ahead and choose up to point O. Forms a nice right triangle right there. That could potentially be useful, knowing that. So 90-degree angle, and this is my height. All right, last example for identifying bases and heights of trapezoids. Which lines are parallel? Because those have to be my bases. Are those parallel? No. Those parallel? Definitely not. That looks ridiculous. Are those parallel? Yes. So those are my parallel lines. Those are my bases. So I'm going to let line QR be base 1 and line TS be base 2. It doesn't matter which one's base 1 or 2. Next, put a straight edge on one of your bases. Make your 90-degree angle. And I'm going to try to form a triangle or another shape in there. So I'm going to choose to draw my height right up there to point T. So this would be my height. Again, trapezoids are unique in that they have 2 bases, and the height is simply a perpendicular line that connects the 2. All right, we have 2 practice examples of using the area formula for a trapezoid. First one, we are simply going to find the area of a trapezoid. In the figure, TUVW is a trapezoid. Line TW is parallel to line UV. What does that mean? That means those are your bases. So I'm going to go ahead and label those. So line UV, I'm going to say is base 1, and line TW is going to be base 2. The parallel lines will be your bases. Next, what does the question want? What's the area of trapezoid TUVW? Pay attention to these letters if you are given them. They tell you specifically what you want. As you'll realize later, especially in part 2 video, shapes are made up of multiple shapes, so the letters that they give you tell you specifically what you're talking about. All right, what else do I need? I need to know my height. I see my right angle right there, So that means 14 is my height. Okay, so what do I do now? First, write your formula. This is a trapezoid, so formula for a trapezoid is A equals 1/2 times height times, in parentheses, B sub 1 plus B sub 2. Next step, substitute. Do I know the area? No, so leave it as A equals 1/2. Do I know the height? Yes. The perpendicular distance between base 1 and 2 is 14. Next, parentheses, do I know base 1 and base 2? My base 1 and 2 are 26 and 12. It doesn't matter which order. Why? Because addition is commutative. You can add in any order you want and still get the same answer. So 26 plus 12. Next step, follow PEMDAS. What does this mean? Order of operations. Parentheses first, exponents next, multiplication or division next, and then addition or subtraction. So, A equals, I see parentheses first, 26 plus 12. I must do that first. So I'm going to write 1/2 times 14, not going to do it, leave it alone, and I'm going to focus on the parentheses first. 26 plus 12 is 38. Next step. There are no more parentheses and stuff to do inside. These parentheses simply mean multiply. There are no exponents. Oh, there is multiplication or division. There's multiplication. So I'm just going to simply work it left to right. So 1/2 times 14 is 7. Bring down my times 38. One more step. Area equals, what is 7 times 38? 266. 266 what? A is for area, so I need area label. Centimeters squared. What does that mean? That means this trapezoid can be covered in 266 square size centimeters. Is that what I wanted? Yes. So this is our answer. We have one more example. Apply the formula for area of a trapezoid. It says the area of trapezoid ABCD is 4,196.5 square meters. Line AD is parallel to line BC. That means this is going to be base 1, and this is going to be base 2 because those are my parallel lines. Next, it says find the area of triangle ADC. So focus on the letters A, D, C. That means it wants the area of the top skinny triangle, not the bottom. It doesn't want the area of the whole thing. It already gives it to you. So what do I do if I want the area of this triangle? Well, I would need a formula, right? Formula for triangles is A equals 1/2 times base times height. So, do I know the base of this triangle? Yes, 56. Do I know the height? No, I do not. But I'll notice that the height of this triangle is the very same height of the whole trapezoid. It's the same. So this distance right here is the height of the trapezoid. This distance right here also is the height of your triangle. So what does that mean? That means if you find the height of the trapezoid, you'll know the height of your triangle, and you can find out your area. So, 2 steps. First step, we're going to find the height of the trapezoid. Again, why am I finding the height of the trapezoid if I just want the area of the triangle? Well, I need the height of the trapezoid, so I'll know the height of the triangle. Why am I focusing on a trapezoid? Because it gives me its area. It gives me both bases. So it gives me more information about the trapezoid than it does the triangle. Okay, what's the formula for trapezoid? A equals 1/2 times height times, in parentheses, b sub 1 plus b sub 2. Next, fill in what you know. I do know the area. The area of the trapezoid is 4,196.5. So 4,196.5 equals 1/2. What's the height? I don't know the height. That's what I'm trying to find. So keep your h, leave the variable, parentheses. What's my base 1 and my base 2? Base 1 and 2, 98 and 56. So 98 plus 56. Next step, simplify and do what you can. So 4,196.5 equals, parentheses first, so 1/2 times height times, what's 98 plus 56? I really shouldn't be using a calculator for this. I'm pretty sure it's 154. So 98 plus 56. Yes, I should believe in myself. Unless I was a unicorn. Then I shouldn't believe in myself because then I'd be fake. So 154. Next, simplify further. So 4,196.5 equals, what's 1/2 times h times 154? Well, 1/2 of 154 is going to be 77. Bring down your h. So 1/2 times h times 154 is 77h. Last step, I need h by itself. So what needs to go away? The 77. What are they doing? They're multiplying 77 times h. So I do the opposite to get the variable by itself. So divide by 77 on both sides. The right side, the 77's cancel, leaving you with h equals, and what's the answer for this one? Not doing that in my head. 4,196.5 divided by 77, 54.5, or 54.5. 54.5 what? This is height, so 54.5 meters. Is that my answer? No, it's not. Why did I find it? Well, we just now found that the height is 54.5. Why do I need that? Well, now I know the height of the triangle. If I know the height of the triangle and I know the base of the triangle, I can use the formula for area of a triangle and be done with this. So, use this to do your second step. The second step is find what you want. Find the area of Triangle ADC. So I need an area formula for a triangle. A equals 1/2 BH. All right, next step, fill in what you know. Do I know the area of the triangle? No, that's what I'm trying to find. So A equals 1/2 times, what's the base of the triangle? Don't use this base. I want the skinny triangle on top. So base is 56. What's the height of the triangle? Oh, well, it happens to be the height of the trapezoid that I found, 54.5. All right, next step, start working it left to right. It's all multiplication. So 1/2 times 56 is going to be 28 times 54.5. So last step, area equals, what's 28 times 54.5? 1,526. 1,526 what? This is area. So area is going to be, in this example, meters squared. So this kite-like shaped trapezoid, actually, well, no, just half of it, not even really half of it. The triangle portion is 1,526 meters squared. So imagine a pretty large square, and you've got 1,526 of them. It's a pretty large area. Perhaps it's a large field. Okay, so anyways, I found the area of the triangle. That's what the question wanted. So this is my final answer. All right, again, this was part 1. It focused specifically on area formulas for trapezoids and parallelograms in the heights and bases. In part 2, that I encourage you to check out, covers composite figures and the idea that shapes are made up of multiple shapes, and you can find the area of them more than one way. I hope this has helped. If it's not, I hope you can find what you're looking for elsewhere. Y'all have a great day.